So one final little piece which we need to do with vectors. Okay. Why is this thing important? So we've just looked at the dot product or the scalar product. Okay. But why is this important? Can you put your phone away, please? Why is it actually important? Well, it can be really useful when you come to look at finding angles between vectors. Okay? So a dot product or a scalar product, so the dot or the scalar product, is useful for finding angles when it comes to vectors. Okay? So if you want to find out how far apart two vectors are facing, okay, so if you travel on one vector, travel on another vector, you want to understand what angle is kind of the difference between those two, you can use the dot or the scalar product in order to do it. Okay? Now, rather than just giving you the formula, I'm going to show you where it comes from because it actually builds on some of the ideas that we've met before in the last theme, which was in trigonometry. Okay? So, can anybody remember the cosine rule? So if I give you a triangle that looks like this, let's suppose that's A, that's B, that's C, which means that's little a, that's little b, and that's little c. Can anybody remember the cosine rule? Good, exactly. So that's one version of the formula. Can you give me the other version of the formula? So a squared equals?
B squared plus c squared minus 2bc cosine a.
Perfect. Okay, where a is the angle which you want to find, and a is the side which you want to find. Okay, you happy with that? Right? So I'm going to play on this idea, but try and relate it to vectors. So let's suppose I give you two vectors. I give you u, which I'm saying is u1, u2, and u3. Okay, and I'm giving you v, which I'm saying is v1, v2, and v3. Okay, so let's suppose that this is u. Let's suppose this is u. Okay, so that's u there, right? And let's suppose that this is v. Right, so that's v there. Now you notice how I've drawn these two things. I've literally drawn the start of each vector so they're starting at the same position. Is that okay? Yeah? So each vector is starting at the same position. What I'm interested in is finding this angle in here. So I'm going to call that angle in there theta. Okay? That's the angle which is going to separate those two vectors. Okay? So how far apart are these two vectors facing? Is that okay? Right. That's what I'm interested in finding. So think about it. I'm going to try and use the cosine rule in order to do that. So what vector am I missing in order to get, or what am I missing in order to build a triangle? Good. It's this thing here. Okay? Yeah. Now, it doesn't matter which way round I'm going to do it. I'm just going to say that that vector is facing in this direction. So from top left to bottom right. Is that okay? Good. What would that vector be? How could I write that vector in terms of v and u? So think about it. All a vector means is you start from this point and you finish at this point. Can you find me a path that starts at this point and ends at this point which uses u and v? Perfect. Backwards along u, forwards along v. Okay? So negative u plus v, or you could, if you like, write that as v minus u. You happy that's exactly the same thing? Okay, good. So v minus u. Now think about it. With this isn't quite the same as this yet, is it? Because up here with this triangle, what was A, B, and C corresponding to? What did A, B, and C correspond to? It wasn't a vector. What was it corresponding to? So what's this A corresponding to there? Not quite, because remember that's my vector. That's a vector. This A corresponds to a length. You happy with that? It's not a vector, it's a length. Okay? But that's fine. I can easily find the length of each vector, right? The length of each vector, I can just write like this. Happy? Then my cosine rule will hold, because now I'm dealing purely with lengths rather than with vectors like I was before. Okay? So let's put all this into my cosine rule. Okay? So what would I get if I put all of this into my cosine rule? So what would my a squared correspond to? Yeah, that thing. So v minus u. So the length of v minus u all squared. You happy with that? That's literally just replacing that side with that. Okay, so a is v minus u modulus. Okay, that's going to be equal to, well, my b squared, let's just say my b squared is this thing here. So v squared modulus. Yeah? Plus c squared, which is going to be the modulus of u squared. Okay? Minus what? Good, so 2 times the modulus of v times u. Yeah? Times by the cosine of, in this case, theta, because a is my angle. Yeah, so times by the cosine of theta. Does that make sense? I'm literally just replacing this into this formula. Okay? But because I'm dealing with a formula here, it has to be a length. Hence, I'm writing all of these vectors as lengths. Is that okay? Right? Now it's just a case of fiddling around with this. Now, before we do anything further, what would this actually be equal to? So if I just chose u or v, doesn't matter which, okay? If I think about modulus of v squared, what would that be equal to?
Isn't it the gradient? Isn't it the...
What would it be equal to?
Side?
Okay, so if I just said that then, what's that equal to?
The hypotenuse.
Yeah, so how do I calculate it? If u is equal, or if v is equal to v1, v2, v3. So v1 squared plus v2 squared plus v3 squared. Okay? But remember, I don't want the modulus of v, I want the modulus of v squared. So what would the modulus of v squared be? Exactly, just get rid of that square root. Happy with that? Yeah, that's the same thing. Now think about it. This looks very close to something we're already familiar with. For example, if I asked you to find the dot product of v with itself, what would this be equal to?
That?
It would be exactly equal to that, wouldn't it? Because the dot product simply says multiply the first elements together. So if I take v, and then if I take v again, I'm basically taking v1 and multiplying it with v1, or v1 squared. Then I do the second element, which is going to be v2, multiplied by v2, or v2 squared. And then v3, multiplied by v3, which is v3 squared. Then I'd add them all together. So would you be happy that the modulus of v squared, so that thing, will be exactly equal to v dotted with itself? You all happy with that? Yeah? So in other words, whenever I see that going on, I can just rewrite it as, so the modulus of v squared will just be v dot v. Likewise, what would the modulus of u squared be?
U done.
Yeah, u dot u. Okay? That I can't do anything with, so I've got 2 times by v times by u modulus times by the cosine of theta. Okay? Have a think on the left-hand side. That's literally the same thing as that. So would you be happy? It would be v minus u, that's a vector, dotted with itself. V minus u. Happy with that? No surprises? Okay. Now have a look at that. Okay. This just becomes a quadratic. It just simply means multiply these two things out. So I'd end up with v times v, or v dot v, okay, minus 2 lots of v dot v.
Minus 2vu.
Yeah, that's it. 2uv or 2vu. Okay, plus u dot u. Happy with that on the left-hand side? Okay, and the right-hand side I've still got v dot v plus u dot u.
Oh, they're actually all the same.
Yeah, I'm just going to write these two things around the other way. Is that okay? Because multiplication might come out a little bit cleaner. Right? Is that okay? Yep. And so therefore I can do a bit of cancellation, can't I? So the v and the v's are gone. So the v dot v's are gone. The u dot u's have gone. Okay. Let's see what I'm left with. Well, actually, I'm just going to be left with negative 2 lots of u dot v will be equal to negative 2 lots of modulus of u times the modulus of v times by the cosine of theta. Yeah? Are you happy as well that I can do a bit more cancellation? The negative 2 and the negative 2, divide through by negative 2. So therefore I'm saying that u dot v will be equal to the modulus of u times by the modulus of v times by the cosine of the angle between them. Remember, theta is the angle between my two vectors to start off with. Is that okay? This formula here is the thing which I wanted to show you. This is in the formula booklet, so you don't need to worry about it, but you can see where it comes from. It's not that hard to derive, yeah? It's just simply the cosine rule, literally where it comes from. Are there any questions about that?
So I'm just kind of confused. When it's u without the two lines in between, that's just a point.
Ah, yes, so this just simply means take the length of u, take the length of v, multiply those two lengths together. Yeah? Whereas this actually has another meaning. Yeah, because I can show to you that's simply the same as taking that vector and dotting it with itself.